Okay, so I'm Joe. I teach sometimes at DU computer science. Mostly I work in a lab doing mean things to little computers, like shooting laser beams at them and trying to get them to fail, which I have not got working yet beyond what you've already seen me do, but I'm working on it. Okay, so homomorphic encryption, also known as the technology that desperately needs a sexier marketing name, is key, I think, for using cloud securely. It's the logical next step after public keys. It lets you upload your most sensitive data to the cloud without handing over control to the cloud provider. It means doing arbitrary computation on encrypted data without the cloud provider learning anything about either the inputs or the outputs. This has obvious applications to healthcare information. But there's a problem with it. It's horribly inefficient, needing literally 1 trillion operations to do the equivalent of 1 + 1 = 2. So it's not exactly practical to use right now. But let me tell you a story. Way back in 1977, there was another technology that was mathematically interesting, but completely impractical. It was such a complicated algorithm that only the largest computers in the world could run it. So it's completely impossible to use this for protecting financial information. Now, of course, RSA is everywhere. It's used in just about every financial transaction. And today, that same algorithm runs on a chip embedded in your credit card. Let me tell you another story. Today, the Diffie-Hellman key exchange happens on just about every web page load. But there was a brief stretch of time back in the mid to late 1990s when crypto accelerators were a thing. These were PCI cards, expensive ones, that you could buy and put in your web server so that your web server could accept hundreds of HTTPS connections per second instead of, like 12. So computation is going non-local. We'd like to be able to do that securely, but that's a problem because maybe I don't want to give the cloud provider all my crypto keys. I mean, cloud storage is nice and all, but what I really want to do is cloud computation. I want to be able to process and search on my data without giving somebody else the ability to keep a copy of my data, which is what would happen if I handed over all my crypto keys. This used to be one of the holy grails of computer science, computing on encrypted data, and it remained unsolved for many, many years until Craig Gentry at IBM cracked this problem in 2009. But it's a little inefficient, like 1 trillion times less efficient than computing on unencrypted data. But we can project how long it should take before computers get fast enough that this isn't a problem anymore. Instead of looking at time, let's look at the rate of increase in computing cycles available worldwide to figure out when there will be enough spare CPU capacity to handle it. I've done this calculation about 3 different ways, and I keep coming up with the same answer. It's going to be about 2028 to 2032 when this technology becomes ubiquitously used. It's going to be the next RSA. Fully homomorphic encryption was discovered in 2009. If it follows a similar pattern, it'll be everywhere by 2032, so 10 or 11 years from now. If you hear of companies that are getting into homomorphic encryption, they might be a good investment, just saying. If you want to learn more about homomorphic encryption, look at the last entry in my list of references. It has a really good survey of all the current tools. That's it.
Awesome. Thanks, Joe. Is this why one of the reasons people keep talking about quantum computing?
No, it's totally separate from quantum computing. This is a purely classical algorithm. I don't know what the effect of quantum computing will be on this. I want to say that people who develop algorithms, they are aware of quantum computing, and they are developing, people who develop cryptographic algorithms are aware of quantum computing, and they are developing quantum resistant cryptographic algorithms. So I would say it probably is not going to have any effect. This is just plain classical algorithm that happens to be incredibly CPU intensive right now.
Cool. Thanks.
But look at this very last paper on the list. If it's on arXiv, if you're if you just want to play around with fully homomorphic encryption tools, there are about a dozen of them available now. It's something that you can actually play with.
Awesome. Cool. Thank you.
Okay, that's it.